Right, product of rational expressions. The objective for today is that in this activity you will learn how to find the product of two rational expressions. So here are some examples of rational expression. We looked at some yesterday also. Steps to multiply fraction is that, or the product of the two rational is you're going to multiply the numerators, meaning you multiply your top of the fraction, the numerators together, and then you're going to multiply the denominator, which will give you the denominators of the solution, and then you will simplify. In some cases you don't have to, it will already be in the simplest form, but in some cases you will have to simplify it. So let's look at the first example here. I put a little bit of the steps. I kind of like put it in a small picture there. So again, to multiply the fractions, what we're going to do is that. There we go. You multiply the numerators together, which is 3 times 1 give us 3. And then 4 times 5 is 20. And then by looking at this, can I still reduce this fraction? We cannot, therefore this is my answer. So pretty easy enough. Alright, let's move on to example 2. Alright, now this time I have 2 over 9 times 3 over 4. So we're going to need to do the same thing. Multiply my numerators together. 2 times 3 is 6. 9 times 4 is 36. Alright, can I reduce this any further? When doing this, what you're looking for is any numbers that are both divisible by numerator and denominator. In this case, yes, I can divide both of them by 6. So I can say 6 divided by 6 divided by 6 is 1, and then 36 divided by 6 is 6. Therefore, my answer for this is 1 over 6. So if we can still simplify it furthermore, then we need to simplify that. So that is one way to do that. Another way to do that is that if you don't want to go ahead and multiply ahead, what we can also do, if I have 2 over 9 times 3 over 4, I can reduce first. If I look at the multiplications of this side and this side, I can see that I can reduce 2 and 4. So I can say, okay, I can divide 2 divided by 2 will give me a 1, and then 4 divided by 2 will give me a 2. And then I'm going to look at my other two numbers, I have 3 and 9. They're both are divisible by 3, so I'm going to divide my first number by 3. 3 divided by 3 gives me 1, and then 9 divided by 3 is 3. Then we have 1 over 3 times 1 over 2. Then we can multiply across. 1 times 1 is 1 over 3 times 2 is 6. You will end up with the same answer. So whether you multiply first and simplify, or simplify before you multiply, you're going to end up with the same answer. Alright, so here is the rule. The product of the two fractions is the product of the numerators over the product of the denominators. Again, you multiply your numerators together, and then you multiply your denominator together. So here is the practice for you. Again, as usual, I'm going to give you 2 minutes to do this, and then we're going to look at this together. Alright, let's look at the first one. To multiply this, again, we'll multiply across, so 2 times 1 is 2, all over 5 times 3 is 15. Can I simplify this any further? Because there is not a number where I can divide both of these by, therefore 2 over 15 is my answer. Very good. And then let's look at the next one. I get 2 and 5, so 2 times 5 gives me 10 all over. 3 times 8 is 24. Can I reduce that any further? Good. Yes, we can reduce it by 2. So 10 divided by 2 is 5. And then 24 divided by 2 is 12. Therefore, 5 over 12 is my answer. All right. Let's continue. Oops, sorry. I thought I was... There we go. Let me leave that up just a second so you guys can see that. Alright, let's look at the next example. What if I have variable and not just all numbers? So we're going to do the same thing. You still follow the same rules. You multiply your numerators together and denominators together. 7 times x is 7x. And 2 times y is 2y. Notice here that I write 7x and not x7. And that is because anytime you write this, the integer should always be written before the variable. So we write 7x instead of x7. So 7x over 2y, I cannot reduce this any further. Therefore, this is my answer. Right, example 4, I have 3x times 3x over 5 times z over y. Again, we're going to multiply across. 3x times z is 3xz. All over 5 times y is 5y. So whether you have 2 variable, 3 variable, does not matter. We're always going to multiply across. So for this one, 3xz over 5y. And we cannot reduce that any further, therefore that is my answer. Alright, example 5. I have 5m over 2 times 3 over 10m squared. Again, we're going to multiply across. So 5m times 3, when multiplying this, you multiply your numbers together. 5 times 3 is 15. I only have one m, so m times 1 is m. All over 2 times 10 is 20, and m times m squared times 1 is m squared. Therefore, now can I reduce this any further? If I look at my number, yes, I can reduce my numbers to they're both are divisible by 5, so I can say 15 divided by 5 is 3, 20 divided by 5 is 4. So I'm going to do that step first, and then I'm going to look at my variable. How about my variable? Can I reduce my variable? So if you will recall from properties of exponents, it say that when you have m, choose a different color. If you have m over m squared, when you divide two equal bases, then you can subtract their exponents. So this is the same as m of 1 minus 2. For that reason, we get m of negative 1. And you cannot write your answer in a negative exponents. Therefore, we can rewrite this as a reciprocal 1 over m. Or if you look here, up here, we have m over m squared. We can say, okay, I have 1m here, and m squared mean there are 2 m's. So what we can do is we can also say, okay, I have m on the top and m on the bottom. I can say m divided by m gives me 1. So you can also do that, or you could do the properties of exponents. Either one, it's going to give us the same answer, 1 over m, just like this, 1 over m. Now that I simplify it, let's look at what do we have left. 3 times 1 gives me 3. All over 4 times m is 4m. Therefore, 3 over 4m is my answer. Alright, any question? Alright, example 6. I have 4 over n times 3 n squared over 8n. This time, as I've been multiplying and then simplify. This time I'm going to see if I can simplify first. Is there anything that I can go ahead and simplify? If I look at my numbers, 4 and 8 are even numbers, and as we know, we can simplify this by saying, okay, 4 divided by 1, it's 4, 4 divided by 2, it's 8. How about and then I have 3 here, and I cannot reduce that with any other number, so I'm going to leave it as that. Then I'm going to look at my variable here. Again, as we did earlier, you can say, okay, n squared means this is n times n. N to the third means this is n times n times n. And then I have another n here. So can I cross out, or can I divide any n's? If we look here, we can say, okay, n divided by n gives me 1. N divided by n gives me 1. So now that I've simplified it, I'm going to do 1 times 3 gives me 3. All over n times 2 times n. So this is 2 times n times n. And then we one last step will be, because I have 2n here, this is 3 over 2n squared. N times n give me n squared, therefore my answer is 3 over 2n squared. Alright, next I want you guys to work on these 3 practices. So same thing, multiply these, find the product of these rational expressions, and then once you finish, once you get an answer, we're gonna go over it real quick. So go ahead and work on it right now. Let's look at this together. Practice number 3. I have 2 over x times 4z over 9. So what we're going to do, we're going to multiply across. 2 times 4z is 8z, all over x times 9 is 9x. Again, you always write your numbers before your variable. And then I'm going to look at this. Is there anything I can simplify? I cannot simplify my numbers. My variable are not the same. Therefore, this is my answer. Alright, number 4, I have 2y over negative 3 times negative 5 over 6y squared. We're going to multiply our numerators together. 2y times negative 5 gives me negative 10y. All over negative 3 times 6y squared is negative 18. Y squared times 1 is y squared. Now, can I simplify this any further? Yes, I can simplify my numbers 10 and 18, and as here you can also see that my negatives, 2 negative become a positive. Then we can say, okay, 10 divided by, what are they both divisible by? They are both divisible by 2, so 10 divided by 2 gives me 5, and 18 divided by 2 gives me 9. Then I'm going to look at my y. Okay, I have 1 y in my numerators, 2 in my denominator. So I'm going to rewrite this as 1 times y, and then cancel out one of them. Therefore, I'm left with 5 in my numerators, all over 9y in my denominator. And I cannot simplify that any more further. Therefore, that is my answer. Alright, last practice example. I have 4m over 9n times 3m squared over 8. We're going to multiply our numerators together. 4 times 3 is 12. Let me go back and choose the same color as we did earlier. So 4 times 3 is 12, m times m squared. So that is the same as m times m squared. When you multiply two bases with 2 equal bases, we add their exponent, which is equal to m to the third. So this is 12 m to the third all over 9 times 8 is 72 times n times 1 is n. Then can we reduce 12 and 72 any further? Yes, they are both divisible by 12. 12 times 1 is 12. 12 times 6 is 72. Therefore, I'm left with, in my numerators, 1 times m3 is m to the third. All over 6 times n is 6n. And that is my final answers for that. Alright, example 7. This time, I am dividing 7 over n times n squared plus 2n over 4. We're still following the same rule. I need to multiply my numerators together and my denominator together. So when I multiply my numerator, it's 7 times n squared plus 2n. I am writing it as this because there are more than one terms in my second fraction. And then I have n times 4. So when doing this, you do not want to distribute. Usually we'll distribute this to get our final answer, right? But this time when simplifying the product of rational fractions, and you do not want to distribute this 7n. What we're trying to do is to see if anything we can actually factor out. So if I look at my parentheses here, I have n squared plus 2n. So I'm going to look for a common factor. Do they have anything in common? Look at my first term, I have n squared. The second term, I have 2n. So it looks like I can factor out an n. So 7 will still be a 7. And then from my parentheses, I'm going to factor out an n. When I factor an n, I'm going to have n plus 2. You can also recheck this and see, okay, if I factor n and if I multiply this, will I get the same thing? N times n will give me n squared, n times 2 will give me 2n. So that is the same thing. So that is just to double check. And then in my denominator, I have n times 4, so this is 4n. Then we need to see if there is anything we can, hold on, let me change this to blue. Then our next step is to see if there is anything we can simplify. Looking at my numerator and denominators here, I can see that they both have n, so I'm going to cross them out. Therefore, my final answer for this is 7 times n plus 2 over 4. You can leave your answer as this, or for our final answer, you can distribute. You can distribute 7 to n, and that gives you 7n plus 7 times 2 is 14 all over 4. So you can either leave your answer as 7 times n over 2, everything over 4, or 7n plus 14 over 4. Alright, example 8. I have m over m squared minus 1 times m squared plus 2m minus 3 all over m times y. So again, our goal is to simplify this. So to find the product of this, I'm going to multiply m times m squared plus 2m minus 3 all over m squared minus 1 times m times y. So notice here that I'm writing each product as in parentheses to differentiate that, okay, this m squared minus 1s are together and m times y's are together. Then our next step is to factor it out. Is there anything I can factor? So let's look at my numerator. Now m, my first term, which is m by itself, will still be m, but then I have m squared times plus 2m minus 3. So we are going to use the x factor to find my to factor this out. My letter C here is -3, and then 2 goes here. Then we're looking for, okay, some factors of 3. What are my factors of 3? It will be 1 times 3. That's the only one. Therefore, my numbers are 1 and 3. Then we need to figure out, okay, is it 1 minus 3 that will give me 2, or 3 minus 1? It is 3 minus 1. Therefore, here, I'm going to come back and say, okay, I'm going to have m, which was m here. I'm going to leave that there. Then when I factor this out, I get my -1 and 3, which is m minus 1 and m plus 3. So that is just my numerator. Then we need to look at our denominator. Okay, for my denominator, here I have m squared minus 1. If you recall from last semester or last year, m squared minus 1, we can rewrite this as m plus 1 and m minus 1. Because if you FOIL this, then we would get m squared minus 1 plus, minus m squared minus m plus m minus 1, which is the same as because my middle two terms cancel out, therefore I have m squared minus 1. So that's just a little bit review of what you may have already known. So let's move on here. So m squared minus 1, I can rewrite this as m plus 1, m minus 1. So I'm going to go ahead and do this. So I have m plus 1, m minus 1, and then I have m times y. Then our last step here is to see if there is anything I can simplify. By looking at this, I have m minus 1, m minus 1. So I'm going to go ahead and simplify that. Can cross them out, meaning m minus 1 divided by m minus 1 gives me 1. Then here I also have m times m, so I'm also going to cross that out. Therefore, I'm left with m plus 3 all over, I'm going to write my y plus times m plus 1. And you can leave your answer as that, or again, you can distribute the y and get your answer. So either one it's the same thing. Alright, example 9. I have a minus b over 9 times 4 over a minus b in parentheses square. So same thing as we did earlier. We need to multiply our numerators. Therefore, I get a minus b times 4 all over 9 times a minus b squared. Now, a minus b squared, when I have this binomial terms in parentheses square, what this I can rewrite this as a minus b times a minus b, meaning a minus b 2 times. Just like if you have x squared, which is equal to x times x. Same thing here. When you have a minus b square, that means you have a minus b 2 times. So we're gonna say, okay, this is 4 again. I'm gonna write my number first, times a minus b all over 9 times a minus b times a minus b, because the square means I have 2 of them. Then looking at this, I have a minus b and a minus b in my numerator denominator. I'm going to cancel that out. Therefore, I'm left with 4 over 9 times a minus b. Again, you can leave your answer as this, or you can distribute the 9 if you want to. Right, so here is your next 4 practice problem. Number 6, I have x plus 4 over x squared plus 2x minus 8 times x minus 2 over 3. So we're going to multiply across, and I get x plus 4 times x minus 2. And then in my denominator, I'm going to go ahead and factor this out. I have x squared plus 2x minus 8. So we're going to do our factor, x factor. My number here is negative 8. And then here is 2. Okay, one number, or when I multiply, I get 8. I can do 1 times 8. I can do 2 times 4. Let me go back real quick. Say I can do 8. I can do 1 times 8. 2 times 4, 3, no, okay. And then by look at this, I can see that 2 and 4 will work. Then we need to figure out, okay, is 2 minus 4 gives me 2 or 4 minus 2? It is 4 minus 2. Therefore, my factor are negative 2 and 4, which gives me x minus 2 and x plus 4. Then I need to multiply by the 3 here, so that is times 3. From there, we're going to say, okay, is there anything I can factor? I can divide out. So I have x over x plus 4 over x plus 4 gives me 1. And then x minus 2 over x minus 2 give me 1. Sorry, therefore my answer is 1 over 3. Right, number 7, I have 3y over y squared minus 16 times y plus 4 over y squared. So again, we're going to multiply across, which give me 3y times y plus 4 all over. Here we're going to do the same thing. We're going to go ahead and factor this out. Y squared minus 16 gives, the factor of those are y minus 4 and y plus 4. Now, how do I get that? How I get that is that if you have y squared, a square root of y squared gives me y, and then you take a square root of 16, which is 4. And then when you have y squared minus a square minus another square, your product of these factors will be y minus 4 and y plus 4. As I showed you guys earlier, when you have that as up here with 1, then the middle 2 terms cancel out. So your answer will be 1 is with a positive and the other is a negative. Therefore, my answer here are y minus 4 and then y plus 4. Then lastly, I need to see if I can cancel anything out. I can cancel y plus 4 and 1 y plus 4, which gives me 1. Therefore, my answer is 3y all over y minus 4. Right, number 8, I have y squared minus x squared all over 6 times 12 over x minus 1. Again, as mentioned earlier here, when you have x squared minus y squared, we can rewrite this as x plus y and x minus y, because the square root of x squared will give me x, square root of y squared will give me y. Then we need to multiply that by number 12, all over 6 times x minus y. And then my last step is to see if there is anything I can cross out in my numerator and denominator, x minus y, x minus y. Then I have number 12 over 6. I can reduce that by doing 6 divided by 1 is 6, 12 divided by 2 is 6. Therefore, my answer for this is 2 times x plus y. I do not have anything left in my denominator, meaning this is over 1. But we don't have to write over 1. Therefore, my answer for this is 2 times x plus y. Or you can, like I mentioned, you can distribute the 2 and get 2x plus 2y, which is going to be the same thing. Then number 9, I have 3x minus 6 over x plus 5 times 2x plus 10. All right, let's look at the first denominator with my first fraction. I have 3x minus 6. Can I factor anything? Yes, I can factor out a 3, and I'm left with x minus 2. And then on my second numerator here, I have 2x plus 10. I can also factor out a 2 and be left with x plus 5. All over x plus 5 and x minus 5. Then again, we're going to see, okay, is there anything I can cross out in my numerator and denominator? Is there anything divisible? I have x plus 5 and x plus 5. This is x minus 2, x minus 5, so I cannot do that. But I do have two numbers, 3 and 2 here, so I need to multiply those two. 3 times 2, it's 6, so I have 6, x minus 2, 6 times x minus 2 all over x minus 5. In summary, there we go. The rules for multiplying rational expression are the same as though multiplying fractions. You multiply your numerators together, gives you your numerator solution. Multiply your denominators together, you get your denominator solution. And then lastly, you want to simplify. And as we look at a few examples earlier, you will try to cross out common factors before you multiply, and then you can always simplify afterward if necessary. And here is your homework. I am going to upload this in Google Classroom. Give me a second. I'm going to do that. And like usual, remember you need to give me your practice problems and your homework to submit it. Practice problems count as your classwork grade. Homework is for a homework grade. So make sure you submit both of them to me.